Alrighty, we're in Unit 4, Part 4, this time looking at the different parts of an isosceles triangle. These and the next set of notes are both on isosceles triangles, and really this time we're just setting up what they are. So we're going to define them, look at their parts, and then on the back of this sheet we're going to look at some numbers for isosceles. But we're starting from the ground up, literally by defining what an isosceles triangle is. Now, an isosceles triangle is just any triangle where two sides are congruent. So we've got a whole bunch of vocab words for the different parts of an isosceles triangle. These really aren't too bad. If you can identify your legs and your base, you've got everything figured out right there. So for a person, you want to hope that both of their legs are the same length, right? Well, for an isosceles triangle, its legs are the two congruent sides. They're the two sides that have the same length. Just like you want your legs to be the same length, in isosceles triangles, legs are the same length. So for this isosceles triangle, my two legs are AB and CB. AB and CB. My base is the other side. It's the side that isn't the same length. You can think of it as the bottom or the base of the triangle. That'll be, in this case, AC. It's going to be your side that doesn't have the tally marks because it's not the same length. Now, your base angles are the two angles that are connected to your base. Angle A, angle C, touching the base, so they're my base angles. Now, my vertex is the other angle. It's the angle at the top of the triangle. So think of it like a pyramid. I have a base on the bottom. I have two towering legs that climb up to the top. And at the very top of my triangle is the vertex. This is going to be my angle B. So base angles, vertex. So these questions here are having us identify different parts of our isosceles triangle. I'll actually go ahead and let you pause for a second. I want you to see if you can find the base angles for these two, and then the equal sides for these two. Okay, now that you've paused and filled them in yourself, I'm going to go ahead and write my own answers. Again, if you haven't paused and tried to answer these yourself, you should go ahead and do so. So, my base angles for these two triangles are going to be angle R and angle S, and then angle W and angle Y. These are all my base angles because they're touching the bottom of my isosceles triangle. Okay, the equal sides. These are going to be my legs, and they climb up to the vertex at the very top. So it's going to be MC and MP. Here, it's going to be DF and DE. So, we've got a theorem at the bottom of this page. This is the whole combining idea for an isosceles triangle. And to really get the point across, I'm actually going to go ahead and draw a little picture on the side of my page. I want you to draw what I draw, which is going to be a really, really extreme scaling triangle. I don't like that one. I'm going to try again. I'm going to have a really short side, a really long side, and then across from it, a semi-long side. Something like this little triangle. Notice that the shortest side is across from the smallest angle. The longest side is across from the largest angle. And the middle side is across from the middle angle. Again, shortest side, smallest angle, largest side, longest side, largest angle, middle. It's easy to see that the size of an angle and the length of its opposite side are related. I mean, take a look. If I've got a really wide angle and a really thin angle, it takes way more distance to cross the wide angle than the thin angle. The point I'm really getting at here is that the wider an angle is, the longer its opposite side is going to be. So, for this isosceles triangle here, both of these sides are the same length, AB and then CB. Both of these sides are the same length, so their opposite angles have to be the same angle measure. Since these sides are the same length, their opposite sides are going to be the same angle measure. In this case, angle A is congruent to angle C. This is our theorem. If two sides of a triangle are congruent, then the angles opposite to those sides are also congruent. All that's saying is the base angles of an isosceles triangle are also congruent. If I have two congruent base angles, I know I have an isosceles triangle. That's what we were looking at here and here. Okay, once you've got that down, let's go ahead and flip it. Okay, we can also go ahead and say the converse of that theorem. If two angles of a triangle are congruent, then the sides opposite of those angles are also congruent. The sides opposite of those angles are also congruent. So what that means, if these angles are the same, these sides also have to be the same. Both of the theorems are really just saying the same thing, just in the opposite order. If the base angles are congruent, then the opposite sides are congruent. Okay, so we've got practice. I'm going to go ahead and work out all of the odd questions on 1 through 10, and then I'll let you pause to answer all the even questions. So, we're told that in this picture on the right, segment AC is congruent to segment AD. I'm going to go ahead and highlight those. Name two congruent angles. Okay, using our theorem above, we know that our base angles are congruent. So, that's going to be as simple as saying angle C and angle D. There are base angles, so they're going to be congruent. Angle C, angle D. Now I want to note that the proper way to refer to this angle C is actually going to be BCD. And the reason why is because there are multiple little angles for C, so we have to be specific when we say BCD. Okay, number 3. Looking at this picture on the right, we're told that angle EBA and angle EAB are congruent. Name two congruent segments. Okay, we've got our base angles here, so the opposite segments are congruent. That's going to be segment AE and segment EA. I'm sorry, segments BE. Okay, moving on to 5. For question 5, we're told that our base angle right here is 60. I need to find the measure of angle ABC. Okay, this is one base angle, and because I know these are my congruent sides, I know this is also a base angle. Easy. This is 60, that's 60. Down here, these are my base angles, which tells me that these are congruent sides. 2x plus 4 equals 3x minus 10. Well, they're equal to each other. So, all I have to do to solve for x is set 2x plus 4 equal to 3x minus 10. I do operations on both sides, add 10, minus 2x, and I get 14 equals x, giving me my answer. Lastly, for question 9, I see again that I have two congruent sides, so all I have to do to solve is set them equal to each other. 2x plus 6 equals 3x minus 6. Again, operations on both sides. I'm going to add my 6 over, add my 6 over, subtract 2x over, subtract 2x over. I have 12 equals x. Okay, go ahead and pause. Try the even questions. I'm going to write the answers in just a moment, but I'm not going to show my work. So I need you to pause, try answering the questions yourselves, and then check your answers with mine once you're done. Okay, go ahead and pause. Now let's look at those answers. So for question 2, we had angle BCE and angle BEC. Question 4, I had segments CE and CD. The measure of angle EDF is 70 degrees in question 6. In question 8, x equals 21. And in question 10, x equals 12. Okay, as always, let me know if you have any questions at all. You're welcome to join me in AAP. And thank you very much. Have a wonderful rest of your day.